Good evening, student. I am Kamlesh Yadav. So today I am going to discuss with you inverse trigonometry function. So first of all, we know that the trigonometry functions are not invertible for their domain. So how to define for inverse function? So let us take an example. Suppose fx equal to sin x. So sin x we know that it is not invertible when x belongs to R. So in order to get the inverse, we have to define the domain as here x belongs to minus pi by 2 plus pi by 2. So if says that minus pi by 2 plus pi by 2 tends to minus 1 to 1. So in this domain and range, here we see that the function fx equal to sin x which is invertible. So the inverse which is represented as y is equal to sin inverse x, and in bracket way here we can write minus pi by 2 less than equal to sin x less than equal to pi by 2. Okay. Actually here sine inverse x, not sin x, but the minus pi by 2 plus pi by 2, which is between sine inverse x. Okay. Then we go for the another functions like y is equal to cos x. So cos x, which is also not invertible for x belongs to R. So that's why it's become invertible when f says that 0 to pi tends to minus 1 to plus 1. Okay, so in this domain and range, the function cos x, which is become invertible, then case of tan x, which become invertible when f says that minus pi by 2, comma pi by 2 tends to minus infinity to plus infinity. Okay, then the case of cot x. So it's become invertible when f says that 0 to pi tends to minus infinity to plus infinity, right? Then case for sec x. So it's become invertible when f says that 0 to pi minus pi by 2 tends to r minus of minus 1 to 1. Okay. And what about the cosec x? So cosec x become invertible when f says that minus pi by 2 minus 0, which is tends to r minus of minus 1 to 1. Okay. So in this domain range, these functions are become invertible. So now we discuss about the graph of inverse trigonometry function and find their domain and range. Okay. And also we know that the inverse function like f inverse x, which is the mirror image of fx, right? So let us start. So the graph of y is equal to sine inverse x. Okay. And I already told you that f inverse x, okay, f inverse x is the mirror image of fx. So here y is equal to sin x. We know that the graph of sin x, which is draws like that, pi by 2, pi, 3 pi by 2, then 2 pi, minus pi by 2, minus pi, minus 3 pi by 2, and minus 2 pi. Okay, so the graph of sin x, this is the graph of sin x. Okay, now we draw the graph of y is equal to sin inverse x. So the mirror image of this function actually like this. Suppose this is pi by 2, pi, minus pi by 2 and pi. This point is 1 and this point is minus 1. Okay, so the graph here it is draw like that. Okay, and this is the point 1 and here minus 1. Okay, so according to this graph, here we see x belongs to minus 1 to 1, which is our domain here, right? Then what about the range? Here we see that y, which is belongs to minus pi by 2 plus pi by 2 close interval. Okay, so this is the range. Understood? Suppose here we have a function like sine inverse x. Then we put the value of x in this question. Then we get sine inverse of 1, which is equal to what? Pi by 2. And when we put y is equal to sine inverse of x na, so x equal to minus 1. So sine inverse of minus 1. So which is equal to minus pi by 2. So here range is what? Close interval minus pi by 2 plus pi by 2, right? So this is the graph and domain range of sine inverse x. Then we go for the next graph. Y is equal to cos inverse x. Okay. So the graph of cos x, we have idea and we know that the graph of cos x be like that. Okay. And this is the point pi by 2, pi, 3 pi by 2 and so on. Then here, this is the point minus pi by 2, minus pi, minus 3 pi by 2 and so on. So now we draw the inverse mirror image of cos x. So it's like this format. This is a mirror image, right? Like this. And where it is meet, this point is 1 and for that side, which is equal to minus 1. Okay. So according to this graph, here we see the domain and range. First of all, domain. It means, see, I mentioned the point. Actually, this is the point pi by 2 minus pi by 2. Then here it is a pi minus pi. Okay. Then here domain and this point where it is mid. It means x belongs to 0 to pi. Okay. This is domain. I already write here. This is domain. And what about the range? So range, actually this is the range. Okay. I'm wrong here. X belongs to minus 1 to plus 1. Okay. See, because here curve which is meet in 1 and minus 1. So that's why x belongs to minus 1 to plus 1, which is domain. Okay. And what about the range? Range C, which is y. Hai na? Y belongs to 0 to pi. Okay. So this is the domain range of cosec inverse x. Now we go for the next graph. Y is equal to tan inverse x. Okay. So first we have idea about the graph of 10x. So for 10x, pi by 2 minus pi by 2, pi, 3 pi by 2, 2 pi, minus pi, minus 3 pi by 2, minus 2 pi. Okay, so the graph of 10x, we know that in these points, 10x is not defined. So that's why I draw the strip line here, plus minus pi by 2, plus minus 3 pi by 2. And the graph like this is the graph of 10x, right? Okay. Now, here we sketch the graph of tan inverse x. We draw the mirror image of 10x. Like this. This is a straight line. Okay. Pi by 2. And next for this side, which is equal to minus pi by 2. Okay. So the mirror image, which is like as that. Okay. Okay. So here we see this is the graph of tan inverse x. Then what about the domain and range? So first of all, domain. It means where the curve is lies. And here we see the curve which is lies between x belongs to all r, right? X belongs to r. Then what about the range? See our range, our curve which is lies between minus pi by 2 plus pi by 2. No? So y belongs to minus pi by 2 to pi by 2 in open interval, right? So this is the graph of tan inverse x and the domain and range is this. Okay. Now next graph is y is equal to cot x, cot inverse x. Okay. First, we draw the graph of cot inverse x. So the graph of cot x like this: pi by 2, pi, 3 pi by 2, 2 pi, minus pi by 2, minus pi, minus 3 pi by 2, and minus 2 pi. Okay. And we know that the cot x, which is not defined in where? Which is not defined in pi, 2 pi, okay, then minus pi, minus 2 pi, right? So the graph of cot x like this. Now we draw the graph of cot inverse x. So we draw the mirror image of this graph. Okay. So this is the strip line, okay, minus pi, or actually this is pi and this is minus pi, okay. Then the graph of cot inverse x is like that, okay. So this is the graph of cot inverse x. So here, domain, it is clearly seen that x belongs to R. And what about the range? So here range, we see, which is where our curve is lies, which lies between 4 cot inverse x now. So which is 0 to pi. Okay, which lies between 0 to pi. Now we go for the next graph. Next graph is y is equal to sec inverse x. So first we draw the graph of sec x. Pi by 2, pi, 3 pi by 2, 2 pi, minus pi by 2, minus pi, minus 3 pi by 2, and minus 2 pi. Okay. So first of all, this is the sec x ना. So first we draw the graph of cos x. तो cos x का जो graph होता है, this is point is 1 and minus 1. So the graph of cos x be like this. Okay. We draw the strip line here. Okay. And we know that the sec x, which is not defined in minus pi by 2. Why? Because sec x, which is equal to 1 upon cos x, and 1 upon cos pi by 2. It means cos pi by 2 is 0, undefined. So that's why this is, in this point, the sec x is not defined. So that's why I draw the strip line here. Okay. So the graph of sec x like this. Okay. So this is the graph of sec x. Now we draw the graph of sec inverse x. Okay. So here, see, like this. Okay. This is pi. This is pi by 2 and 0. Okay. And this is the point 1 and this is the point minus 1. Okay. So now we draw the inverse image. So here we draw the inverse image like this way and this way. Okay. So according to this graph, what is the domain? See, where our curve is lies, so which is lies between r minus of -1 to 1 in open interval. Then what about the range? Okay, see range y belongs to, which is draw in 0 to between 0 to pi and subtract from minus pi by 2, right? Yes, y belongs to 0 to pi, okay, in closed interval, then minus of pi by 2. See, according to this graph, our curve which is lies between 0 to pi, but except the point pi by 2. So that's why I write here domain y belongs to 0 to pi and minus of minus what? Pi by 2. Okay. So this is the graph of sec inverse x and the domain and range is this. Okay. Then we go for the last graph. The last graph is y is equal to cosec inverse x. Okay. See, and we know that the graph of cosec x, so cosec x, right? So first we do the graph of sin x. Pi by 2, pi, 3 pi by 2, then 2 pi. Minus pi by 2, minus pi, minus 3 pi by 2, and last one is minus 2 pi, and so on. Then this point is 1 and minus 1. First I drew the graph of sin x. So the graph of sin x like this. Okay. And we know that the cosec x, which is not defined where? Which is not defined in pi. See, why it is not defined in pi? Because cosec x, which is also write as 1 upon sin x, when we put sin x and put the value of x equal to pi, 1 upon sin pi, and 1 upon sin pi, it means 1 by 0, and which is become not defined or undefined. So that's why in this point, the cosec x is not defined. So I draw the strip line here. Similarly for 2 pi, again for minus pi, and again for minus 2 pi. Okay. Now the curve which is lies between like this. This is the graph of cosec x. Now we draw the mirror image of this graph. It means graph of cos inverse x. So let us start. See the graph. Okay, this is the point pi by 2 and minus pi by 2. And mention this point here. This is 1 and this is minus 1. Okay, now we draw the mirror image. See how to draw here mirror image. So first mirror image which is draw is like that, and also for yes, no, also draw for this side. Okay, the mirror image. Okay, so this is the graph of cos inverse x. So now we discuss about their domain and range. See, where x, the value of x belongs, which is belongs to all r minus of -1 to 1. Okay, because our curve which is lies all are except the point 1 and -1. So that's why the domain is x belongs to r minus of what? -1 to 1. Okay, then what about the range? Okay, so range y belongs to C, where our curve is lies, which is lies between minus pi by 2 to pi by 2. But except this line, x-axis minus 0, right? So this is the domain, range, and the graph of cosec inverse x. Okay. So we discuss in details of inverse trigonometry function. Now we have to see some another types of trigonometry functions, inverse trigonometry function. Okay, so let us start. The question is, see, question is sketch the graph of C. Y is equal to sine inverse of sine x. First question. Second question is cos inverse of cos x. Next one is y equal to tan inverse of tan x. Y is equal to cot inverse of cot x. Y is equal to sec inverse of sec x, and y is equal to cosec inverse of cosec x. Okay, and all these inverse trigonometry functions, we know that this is a periodic functions. Okay, what is a periodic function? Periodic function, it means if we draw the graph, when the graph is repeated to the fixed point, that is called a periodic function. Suppose we have a graph like this. Okay, this is the graph, and here we see, suppose this is a point 2 pi. So this graph is repeated in 2 pi. Actually, this is the graph of sin x. Okay, so which is repeated. The graph is repeated in the point of 2 pi. So this is a periodic function, and with periodic value which is 2 pi. With periodic value 2 pi. Okay, when the graph is repeated in the fixed interval. Okay, so these all trigonometry functions are periodic function. So the domain and range of this all trigonometry function, inverse trigonometry function, which are same like sin inverse x or cos inverse x. Okay, all trigonometry function. So now we draw one by one the graph of this particular questions. So let us start. First is y is equal to sin inverse of sin x. Okay, sketch the graph of this question. So first of all, here the function sin inverse of sin x, it is defined as like as x where minus pi by 2 less than x less than equal to plus pi by 2. Okay, the next value is pi minus x, where it is less, it is defined pi by 2 less than equal to x less than equal to 3 pi by 2. Okay, now we draw the graph. See the graph of this function. So first of all, I mentioned the point here, pi by 2, pi, 3 pi by 2. Next one is 2 pi. Similarly for this side, minus pi, minus 3 pi by 2, then minus 2 pi. Okay, and this is 1 and this point is minus 1. I draw the strip line here. Okay. Okay. So here we see the first value is x. It means y is equal to x. So the first line, this is our first line, y is equal to x, which is drawn between minus pi by 2 plus pi by 2, which is like that, y is equal to x. Okay. The next one is pi minus x. So the value is pi here, pi minus x. Okay, which meets in there. So this is the value of pi minus x. Okay. When we draw about y is equal to minus x, so we draw here like this strip line, it touch on minus pi. Okay. No, that was actually wrong. See, meets in this point, then yes, yes. Then this point actually, which is y is equal to minus x, which is correct. Okay. Then here also we draw the strip line here and so on. Because this is a periodic function, the graph is repeated. So here we see this is the main curve. Okay. And this is the repeated. This is the repeated curve. Okay. So this is the graph of sin inverse of sin x. Right? Okay, minus pi by 2 plus pi by 2. Okay, which is meets, then again meet on pi, which is go for pi minus x. Okay, which is right. So here the main curve, which is like is that. Actually, this is y is equal to not minus x. It is a pi plus x actually. Okay, and so on. Okay, so this is the graph of sin inverse of sin x. Right? See, this result is useful to find the graph of sine inverse of sine 3 theta. Okay. Or sine inverse of sine 2 theta. Okay. Then we go for the next graph. Y is equal to cos inverse of cos x. Okay. So first of all, this graph which is defined as x where 0 less than x less than equal to pi and 2 pi minus x for where pi less than equal to x less than equal to 2 pi. Okay, let us draw. First mention the point 2 pi minus pi by 2 minus pi minus 3 pi by 2 and minus 2 pi. Okay, this point is 1 and minus 1. Okay, draw the strip line here. Okay. So first we draw y is equal to x. Where 0 to pi. It is very important to 0 to pi. So 0 to pi. Okay. See like this. Y is equal to x. Okay. Then which is here. Then again it's meet on up to 2 pi. And the next point is 2 pi minus x. Okay. Then we go for the left side like dotted point. So this is y is equal to minus x and we go for this is minus 2 pi. So this point x plus 2 pi. Okay, 2 pi minus x. Okay, and repeated. So this is the main curve and this is the repeated curve. Understood? So this is the graph of cos inverse of cos x. Okay, now we go for the next graph. Y is equal to, next is tan inverse of tan x. Okay, so it is also a periodic function with period, with periodic function actually with period pi. So let us draw the graph of tan x. Oh, first see where it is defined. This function y is equal to tan inverse of tan x. So which is defined as x and where pi by 2 less than x less than pi by 2. Okay, so the graph of tan x like this. First mention the point pi by 2 pi 3 pi by 2 then 2 pi minus pi by 2 minus pi minus 3 pi by 2 and minus 2 pi. Okay, this is 1 and this is minus 1. Let me dot it like this. So, okay. So y is equal to x. Very simple. 4 minus pi by 2 plus pi by 2. See. Okay. And the another points which is like this. Zero. The next one is 4 minus pi. Open format. Okay. Then 2 pi. This is main curve. What? Y is equal to x. And this is repeated curve. So this is the graph of tan inverse of tan x. Okay. Okay. And also, yes, this is the correct graph. Then we go for the next graph. Y is equal to cot inverse of cot x. Okay. See this function which is also defined as x, but the range which is 0 less than x less than pi. Okay, very simple. So draw the graph of cot inverse of cot x. Pi by 2 pi 3 pi by 2 2 pi minus pi by 2 minus pi minus 3 pi by 2 minus 2 pi. Okay, this is 1, this is minus 1. We draw the strip line here. I think this is a cot inverse x, no, not needed for the minus terms. Okay. So which is lies, where is y is equal to x, which is lies where 0 to pi, 0 to like this, y is equal to x. Okay, now next one is for 0 to, then same for like this, same for like this. Okay, so this is the graph of cortex, cot inverse of cortex, right? Then we go for the next graph. See, the next graph is sec inverse of sec x. Okay, and we know that the sec inverse x, which is same as the graph of cos inverse x, so which is defined first x and second is 2 pi minus x. But here the value, we know that, first I write here, see, in close interval 0 to pi and pi to 2 pi. Similar, I write here with the form of cos inverse x. Okay, so see very careful, pi by 2 and pi by 2 in open interval union format. Okay, and 3 pi by 2 and 3 pi by 2. I'm giving you why I write this format. Okay, see, first of all, we know that in point pi by 2 or 3 pi by 2. Okay, so in this point, the graph of what? Sec x, na? Which is undefined. In this point, pi by 2, minus pi by 2, 3 pi by 2, minus 3 pi by 2. So that's why we skip. Actually, it is clear in our graph. See, first I draw the graph, then I explain. Three pi by 2, 2 pi, minus pi by 2, minus pi, minus 3 pi by 2, and minus 2 pi. Okay. And this is the graph of cosec inverse. No? So, draw the dotted line, which is equal to, y is equal to what? Pi by 2. Okay. See, what I do here. See, here I draw line this, okay, which is meet on pi. Okay. So why I drew this graph like this, and this is open for from, actually this is a point of pi by 2. And we know that sec pi by 2, which is not defined. So that's why I drew this graph, except this point. This line is exits, but except where? Pi by 2. So that's why I drew like that. Okay. Then we go for the 2 pi minus x. This is the line y is equal to x. Then we go for the Smiths on here, but which is open in C, which is open in where? 3 pi by 2. Now you understand. Now you understood why I write here pi by 2, like 0 pi by 2, which is in open interval, right? So that's why, because in this point the sec x is undefined. So that's why I write here this format. Okay. Then similarly, I draw like this. Okay. Okay. So this is the main curve and this is the repeated curve. So this is the graph of sec inverse of sec x. Okay. Now we go for the last graph. See. Now we go for the graph of y is equal to cosec inverse of cosec x. Okay. So which is draw as like as sine inverse of sine x. So which have value x and pi minus x. Okay. And mention the range C, which is lies between minus pi by 2 to pi by 2. Okay. So in 0 union, the next is pi by 2 to 3 pi by 2. Okay. And 0, the next point is 0 to pi. Actually, why I write this point, I can explain in the graph union. Okay. So first of all, I draw the points, mention the points, pi by 2, pi, 3 pi by 2, 2 pi, minus pi by 2, minus pi, minus 3 pi by 2, and minus 2 pi. Okay. Okay. And we know that why I write here, because the cosec x, okay, in 0, which is not defined. So that's why 0 in written as open interval. And again for pi, because cosec pi, which is undefined, so that's why is written in open interval. Okay, so for the graph, see, this is a line y is equal to pi by 2. And this is another line y is equal to minus pi by 2. Okay, so here, where I draw the first line. So first line y is equal to x. Okay, y is equal to x, but except 0. So which is draw as like that, right? Here y is equal to x. Then go for the pi minus x. Pi minus x. So next one is like that, but except this point, then mate is like that. Okay, then similarly go for like that, and similarly for this way, this is in except point, that next one is this. So this is the, actually this is what, pi minus x. Okay, and this is pi plus x. So this is main curve, and this is a repeated curve. This is the repeated curve. Okay. Okay. So this is the graph of cosec inverse of cos x. Okay. So these are some important inverse trigonometry graphs actually. Okay. Now, next is, next question is sketch, see, very good. Sketch the graph for, see the question. Question is sine of sine inverse x. Second is cos of cos inverse x. Third is tan of tan inverse x. Cot of cot inverse x. Then fifth is sec of sec inverse x, and cosec of cosec inverse x. Okay. See, in this type of inverse trigonometry functions, they are not periodic. Okay, not periodic, it means the graph are not repeated in the fixed interval. Okay, so it has not periodic function. Okay, but it has, but they have some restricted, domain and range. Okay, so let us discuss one by one. First is y is equal to sine of sine inverse x. Okay, see. So for the domain, x belongs to -1 to 1, because sine inverse x, the domain is -1 to +1. So that's why x belongs to this form. Then what about the range? This is domain. Then what about the range? So range, here, see, y is equal to x, and y belongs to where? -1 to +1, right? It is clear now? Why I write here x belongs to -1 to +1? Because sine inverse x. So the domain of sine inverse x, which is -1 to +1. So that's why. And what about the range? See, this function y range here y is equal to x now, because sine of sine inverse x. So y is equal to x. And here, if x is -1 to +1, so that's why y belongs to -1 to +1. So the graph here we should hence we should sketch y is equal to sine of sine inverse x only when x belongs to -1 to +1 alone with y is equal to x. Okay. See, first of all, x equal to 1, x equal to -1. Okay. Then what about the y? Y also, actually this is 1 and this is -1. Okay. Now we draw the line like this. Okay. Then our graph, which is plotted between, which is case like this. Okay. This is the graph of sine inverse x. Okay. First question. Then we go for second. Y is equal to cos of cos inverse x. Okay. Then we also know that the domain of cos inverse x, which is also here, x belongs to where? -1 to 1, right? So which is domain. And what about the range? Then range is also y is equal to x, na? So y belongs to where? -1 to +1. So the graph is very simple way. It should be plotted only when where x belongs to -1 to +1 and y belongs to -1 to +1. Actually, y is equal to x. Now, this line is also y is equal to x. So, first mention the point -1, 1 and -1. Okay. Draw the line and y is equal to x. Now, so y is equal to x, which is drawn like that. Then cos of cos inverse x. So, this is the graph of cos inverse x. Okay. Very simple and very easy. Then we go for the third question. Graph of y is equal to tan of tan inverse x. Okay. See, we know that the domain of tan inverse x, which is equal to x now, right? So here, domain, which is x belongs to R. Then what about the range? Range is also here what? Y is equal to x now. So here, y belongs to R. R, it means what? Minus infinity less than x less than plus infinity, right? So the graph can be sketched as like that. First, we mention the point C. Actually, here x belongs to R and y equal to x now. See, it is very simple. This is the graph of tan inverse now, because x belongs to R and y is equal to x. Okay, very simple. Then we go for the fourth question. Y is equal to cot of x. Okay. Then again here domain. We know that the domain of cot inverse x, x belongs to R. It means minus infinity less than x less than plus infinity. Then what about the range? So range, here y is equal to x and y belongs to R. So the graph, it can be plotted as that. Very simple. Y is equal to x now and x belongs to R. So here, this is the graph of cot of cot inverse x, right? Then we go for the next question. Y is equal to sec of sec inverse x. Okay. And we know that the domain of sec inverse x, domain x belongs to where? R minus of -1 to +1, right? Then here range, which is also y is equal to x. Then here y belongs to C. Here y belongs to where? R minus of minus 1 to 1. See, which is also written as like that, y belongs to where? Minus infinity to minus 1, open interval, union of 1 to infinity. Which is same actually. These two statements are same. Now we draw the graph of sec inverse x. Okay, so first r minus of minus 1 to plus 1. First I mention the point 1 and minus 1. Then go for the y. Similar. 1 and minus 1. Draw the line here like that. Okay. Then where the line y is equal to x is draw here. See which is lies in here except the point minus 1 to plus 1. Okay. So this is the graph of sec inverse x, sec of sec inverse x. Okay. Very simple. Then the last question, last one is y is equal to cosec x and cosec inverse x. Okay. So we know that the domain x belongs to cosec inverse x, which is what? R minus of minus 1 to plus 1. Okay. Then what about the range? So range here. Y is equal to cosec x into cosec inverse x. So range which is equal to y is equal to x. And here y belongs to r minus 2 minus 1. And also we can write here y belongs to minus infinity to minus 1 union of r minus actually 1 to infinity. So the graph, it can be sketched as like that. First mention the point 1 minus 1, 1 minus 1. Draw the line and see where the line y is equal to x exits. Its exits except the point 1 and minus 1 like that. So this is cosec of cosec inverse x and sec of cosec inverse x. So for today class, to summarize for today class, we see that the graph of inverse trigonometry functions and solve some questions related with trigonometry function. Actually, we have discussed in the class in graph and their domain and range. Okay. Thank you.